All right, we're gonna go ahead and get started, just to take good advantage of everybody's time. First, I want to start off by thanking Duncan and NDCP. They have been a wonderful partner to WCR since 2018, and you can check out a little bit about our partnership there in the link in the chat. I mentioned that we are going to be taking questions at the end. Stuart's going to have about a 40-minute presentation. And a little bit throughout, we're going to ask you a couple questions. We have a couple of polls that we're going to make live so that we can learn a little bit more about you. And I'm actually going to shoot one of those live to you guys right now. So feel free to let us know where you are calling from. All right, so we have put this little presentation together from Stuart. Stuart is a historian, a professor of history at the University of Guelph in Ontario. And sorry, I'm turning my phone off so it's not beeping at me. And we have invited him here to talk to us about the history of coffee leaf rust and especially rust pandemics, which the topic of pandemics is, of course, pretty topical at the moment. But rust is something that World Coffee Research has focused on for a very long time, from essentially our inception. And the reason that it's a core part of our work and our thinking is because it really is one of the single most significant challenges that coffee farmers face. This is just a really kind of shocking image from a coffee farm in Brazil that shows what it looks like when you have a serious rust outbreak on a farm with varieties that are not resistant to rust. That's over here on the left, and varieties that are resistant to rust. That's over here on the right. So I'll be putting up some links to some information about some of our work on rust. And some of the resources that we have, the technical manuals for managing rust, etc. But today we're going to zoom way out to a much higher level in the clouds and look back at the history of rust and about what we can learn about the sort of present moment that we find ourselves in coffee from looking at some of this history. So we really could not have a better guide than Professor McCook. Stuart studies the history of tropical agriculture, especially export commodities, with a focus on the environmental history of tropical crops. He's looked at a kind of series of catastrophic plant diseases that have afflicted almost every major tropical crop, starting in the mid-19th century when massive kind of widespread crop production started. And he has focused on Latin America. He knows a lot about that, but has also expanded to focus on the global tropics. And he has really focused a lot of his research on coffee rust, which we are very lucky about. And I think one of the things that's so exciting to me about his work, and the reason that I have just absolutely loved the new book that he wrote that came out, which is called Coffee is Not Forever, and I'll put a link to that in the chat in a minute, is that it really gives you a kind of a new way or a new lens on understanding the complexity of coffee production at a global level. So globalization, the interplay between economic, environmental, social, cultural forces, and how those all come to interact through a single disease. I have been so lucky to get to know Stuart, and I am really excited that you're going to get to know him a little bit now. I'm going to go ahead and turn my camera off so that he can talk with you about his work. And we are just delighted to have all of you here with us. So thank you so much for being here. And Stuart, take it away.
Okay. Well, thanks everybody for joining me to talk about something that I've spent I can't believe it, but the last 15 years of my life working on, which is the coffee rust. And it's nice to have an audience who I think will really appreciate what this is all about. I'm going to start by stepping back from the rust itself and just talking about some broad conceptual ideas. As a professor, when I teach classes, I sometimes teach classes in the history of natural disasters and the history of diseases. And there are sort of some underlying concepts that I think are worth thinking about, both when we talk about the rust, but also, for example, when we think about disasters or think about the coffee rust in specific. So often, I think in the popular context, we tend to think about natural disasters, and in this case, I'll just talk about epidemics, as events. This thing seemingly drops out of the blue, disrupts our lives for a certain amount of time, and then goes away. And in the last, say, 15 or 20 years, there's a whole bunch of scholars, anthropologists, sociologists, historians who started to really kind of rethink that a little bit and to say, we really need to understand these disasters, even if they're experienced in a short period of time, really as being part of much longer processes that before the disaster involve a long process in which vulnerability of one sort or another is constructed. Then there's the emergency phase itself, which in the context of the COVID epidemic is probably roughly where we are right now. And then there's the long-term change and recovery or not recovery that you see in the years and sometimes decades after the emergency takes place. So just keep that long-term process in mind, because a lot of my talk today is going to be focused around understanding the coffee rust epidemic in this larger frame. And since some of you are involved in this, I'm sure you'll be able to recognize your own place in this broader story. Kind of related to this, I just want to talk about thinking about disease and thinking about epidemics more generally. And again, this is somewhat related to my previous point. This is the slide you're seeing in front of you is a version of what's called the disease triangle. Often, when we talk about diseases, and human diseases and crop diseases alike, but in this case particularly crop diseases, we often really tend to, or at least casually, we tend to talk about the disease as if the disease was the pathogen, that is the organism that is disrupting things. But really, and particularly in crop diseases, in order to have a disease, you need to have three things. So the pathogen is just one of them. You need, obviously, in addition to the pathogen, there needs to be something to get sick. And that's the circle you see up at the top, which is the susceptible host. And then in agriculture too, often you need to have the proper environmental conditions, and that can be kind of the macro environmental conditions, like the landscape, the rainfall, and things like that. But also the more kind of micro environmental conditions, things like how you farm your coffee, whether you have shade trees, whether you cultivate it as a monoculture, or things like that. And then the other thing, and this is indicated by these little figures I have standing on the edge of each circle, is that these epidemics, and particularly in crops, are never simply natural processes. Particularly since the coffee rust outbreak was first recorded in 1869, what you see is that the life of the pathogen, the life of the host, and the environmental conditions have all been shaped by people. So while these epidemics are natural events, they are also inherently social and historical as well as natural. So just a quick introduction to something which to most of you probably needs no introduction. The coffee leaf rust is caused by a fungus known as Himalaya vistatrix. And the fungus starts off its life as a spore, and in the right conditions, which involve reasonably warm temperature and water droplets, the spores will germinate and penetrate the leaves and start to colonize the leaves. A British scientist in the early 20th century described these fungi as the vampires of the vegetable world, which is a turn of phrase I love and use as often as I can, as I'm doing here. In a bad outbreak, the leaf will be very heavily infected with these lesions and drop off. And collectively, what happens then is if the trees lose too many leaves, the branches and the fruit don't get properly nourished, and you see the situation which is depicted on the photograph to the right, where you've got a bunch of beans on an infected tree, or fruit on the infected tree, which is blackening and almost literally dying on the branch. But if you look at the branch itself, you'll notice that the branch itself is also blackened and dying because it's malnourished. And that is the branch, much of which will bear the following year's crop. So the rust impacts not only the current year's crop, as illustrated by the black fruit, but also the next year's crop, as illustrated by the blackened branch. So, and again, in almost every slide you see today, there's a much deeper and more complicated history. So I'm just giving you very high level stuff. And if you have more specific questions, I'm happy to dive into those in the question and answer period. So let's look at the long-term origins then of the coffee rust epidemic. We know that the rust was first recorded in Ceylon, now Sri Lanka, in 1869. But going back to my initial discussion of epidemics as processes, I want to take us way back before 1869 and think about where the disease, in some ways, the story of the coffee rust really starts. And it starts, and here I invite you to think about the disease triangle, the combination of host, pathogen, and environment here. I'm going to start with the story of the host, because this is really where the story begins. The arabica plant is native basically to southwestern Ethiopia. In the forests of Ethiopia, rust is present, but it's generally, at least in the wild, it historically was not serious. The arabica plant is a widely scattered understory crop. You could say, using modern parlance, that the arabica plants practiced social distancing. I'm sure they didn't do it deliberately. As far as I know, arabica plants don't have that kind of consciousness or mobility. But in any case, so while the rust was present, the fact that the trees were widely scattered and there were lots of other trees in between them acted essentially as barriers to keep the level of rust fairly low in the wild forests of southwestern Ethiopia. But the real key moment in the global history of the arabica plant is when it was taken across the Red Sea from Ethiopia and cultivated in Yemen. And Yemen is interesting in part because it is a landscape in which you can grow coffee, but for a wide range of reasons, turns out to be very, very hostile to the rust. And so essentially, while the coffee plant was transferred across from the Red Sea to Yemen, the coffee rust fungus was not. And that matters to the larger global history of coffee because pretty much all of the coffee, arabica coffee, that was circulated outward from to the rest of the world was circulated not from coffee's wild origin in Ethiopia, but rather from this, you could think of it as a sub-origin on the Arabian Peninsula, and it was a clean sub-origin. So essentially what happened then is even before the age of European empires, coffee was taken to Western Ethiopia, to the India, to the Western Ghats of India, and likely to modern day Sri Lanka, and I think possibly to Java as well. In the 17th century, the Dutch started cultivating coffee in Java. And then in the 18th century, in particular, it was taken first to Europe and then over to the Americas. And so essentially, this host that was highly susceptible to rust, the arabica plant, was able to circulate globally while the disease, for all practical purposes, remained trapped in Ethiopia itself. And so coffee planters all around the world could essentially grow their arabica without worrying much about the disease. The next phase, so what we're left with, as you can imagine then, is a population which is not sick, but which is highly, which if the pathogen were to appear, would be highly vulnerable to that pathogen. The next step, I would argue, probably happens in sort of the construction of the epidemic, again, begins probably in, let's call it the 19th century. I'm a historian, so we can argue about dates a lot, but for practical purposes, In the early 19th century, you see the development of the Industrial Revolution in Europe and North America. For Europe, there's a new age of colonialism in Africa and Asia. And so there's growing consumer demand for tropical commodities, which had previously been luxury goods like coffee and chocolate and tea. And then for the Europeans in Africa and Asia, this was an age of new empires. And if you're going to take over a country, ideally what you want to do is to make it pay. You don't want to lose money while you run an empire if you're a good imperialist. And so one of the ways that a lot of European colonies made their money was through the production of tropical commodities. And this is a photograph. This particular photograph is from Ceylon. I think it's from about the 1860s. I don't remember the exact date on this one, but I particularly love this one because you can kind of see the process of colonization happening in real time. In the backwards, up in the back, up in the mountains, you can still see the edge of primary tropical forest. In the middle ground, you can see trees that have been felled and cleared, but perhaps not yet planted. A little bit closer, you can see young plants, and then right up front, you can see very dense farms of coffee plants. And here, unlike, say, the wild forests of southwestern Ethiopia, these coffee plants are cultivated at very high densities and with very few physical obstacles between one plant to another. So we've got not only the global spread of genetically vulnerable plants, but we also have a new way of reforming the arabica coffee environment in such a way that, at an economic level, I suppose makes sense, and that if you want to maximize your productivity per unit of area, this is a good way of doing it. But it has the unintended consequence of creating a landscape that is highly vulnerable to disease. This is the botanical equivalent of some human epidemic diseases that are known to be crowd diseases, that are primarily diseases of large urban areas, but are less of a problem in rural areas where populations are sparser. So this is in the book really where I start the story of the disease. Is let's not start with the pathogen, but let's look at the construction of vulnerable landscapes. Then the other kicker here is that in addition to empire, in addition to monoculture, in addition to susceptible crops, this is an age of technological revolution as different parts of the world become increasingly connected with one another, and especially after the mid-19th century, they become connected to one another by steamships, which start moving people and goods, and as it turns out, diseases across the tropics and across the globe much more quickly than they ever did before. And so this is an age of tremendous human epidemics. In the 19th century, you see kind of regional outbreaks of cholera, of yellow fever, of the bubonic plague, all of which travel along these networks of steamship lines as laborers, as colonists, as travelers, and other people move swiftly from one region to another, doing voyages in days or weeks that might have taken them previously months. And if you look at Ceylon, which is indicated here, where the coffee rust initially breaks out, it's really kind of literally in the middle of things. So if you go up into the left of Ceylon into continental India, you've got the Western Ghats coffee zones. You're just a relatively short ship ride away from Sumatra to the right, and then a little farther down to the coffee lands of Java. And essentially there are coffee lands ringing the Indian Ocean basin, which up until this point have been healthy and happy. But then one day in 1869, a farmer in Ceylon noticed something a little bit weird on some of his plants and asked a botanist to come and check it out. The botanist said, this looks interesting, sent it off to mycologist, an expert on fungi in the UK, who identified this as who identified it as Himalaya vastatrix, a previously unknown fungus. I will say one of the big questions that comes up a fair amount is how on earth did the fungus get from Ethiopia, which on the map you see before you here appears as Abyssinia? How did it get from Abyssinia to Ceylon? And the answer is, honestly, I still don't know. I don't have a smoking gun. I've seen various theories. But I think the point is, even though I don't have a smoking gun, it's clear that this kind of circumstances of empire and technology in the early 19th century created the conditions that would allow this kind of transfer to happen. So now I'll just run through what happens next. Here's a photograph of the Colombo harbor, roughly from the time of the time that the epidemic was breaking out. And again, you can see this is an age of transition in the age of shipping. In the foreground, we have a bunch of ships that are clearly primarily sail ships, but in the background, we have ships that still have masts, but they also have smokestacks. They're steamships. So what happened was the epidemic broke out in Ceylon. And if you imagine, or you know what, I'll just walk us back for a moment to this picture here. Imagine what happens when a tree like this gets infected. Again, had it been a tree standing alone in the woods of southwestern Ethiopia in the wild, most of the spores that would have been produced by this sick tree would have fallen to the ground harmlessly. In conditions like this, what happens is many of the spores that a single sick tree would produce would then proceed to infect their neighbors. And you get this kind of geometric exponential increase in the volume of spores in the in the coffee farm, and it spread in a matter of years across all of Ceylon's coffee zones, which were bathed by not one but two monsoons and rainfall and winds, and really Ceylon was in some ways the perfect petri dish for the rust fungus, and so it spread everywhere. You can imagine, if you will, for example, an Indian laborer who walks through a plantation, or a planter who walks through a plantation, picks up some spores on their clothes, and then perhaps goes back home to their home somewhere else, or maybe decides to go on to work somewhere else in another part of the Indian Ocean basin. And they carry their spore-laden clothes with them, and then they walk through a coffee farm in their destination and transfer it that way. So very quickly and almost inevitably, people and goods carried the spores almost everywhere in the Indian Ocean basin. And on top of that, it's also clear that the wind carried spores great distances. It likely carried spores from from Ceylon over to Java. And as some of you know, this caused a massive, between roughly 1869 and 1910, this caused a massive collapse of arabica cultivation in Ceylon, Java, Philippines, and other lowlands in the tropics. Just so you know, I'm going to be galloping through a lot of the history here, just giving you a high-level overview, but I can come back in more detail in the question and answer. Coffee rust then starts to, after it's infected most of the Indian Ocean basin, starting in about the 1880s and 1890s, it starts to be registered in Africa. And part of what's going on there is simply, well, not simply at all, but European colonialism. After 1885, basically the European powers divide Africa amongst themselves and start to make serious efforts to colonize their colonies in Africa. And as they had done elsewhere, they wanted to set up coffee farms and other commodity farms to help make their colonies pay. They also extended the transportation infrastructure inward. So they built the Uganda Railway through Kenya, starting at the port of Mombasa up inward to Uganda. And the rust destroyed nascent arabica plantations in German East Africa, which is now Tanzania, in Kenya, and Uganda. And I've sort of reconstructed some of the historical different documents and reconstructed the path of the disease. And you can, in fact, see it moving inward from the coast up along these routes. But once you get into sort of the highland areas of Uganda and some of that area, you're actually also getting into parts of the world where the coffee rust itself is native, and it's found on the wild forest coffees. So as people set up coffee farms in those areas, they wound up kind of getting the rust from two directions, both rust that was introduced from the Indian Ocean basin, from the infected areas in the Indian Ocean basin, and then also rust that was leaping off wild trees. And so what happens there is that arabica, essentially, because of the rust and actually because of a host of other diseases and pests, arabica production only becomes viable at certain highland enclaves, really, where the conditions are cool enough that the rust, you can still cultivate coffee, but that the rust isn't such a big problem, or that it can be controlled one way or another. It also is one of the things, that helps bring a Robusta onto the scene, but I'm going to talk about Robusta in a little while. After mid-century, the coffee rust then sort of spreads. It's a little hard to read the spread of the rust in Central Africa, but after mid-century, basically, the coffee rust then spreads noticeably into Western Africa, which has just had a fairly massive coffee boom. So it hits the Ivory Coast in the 1950s, and it reaches the coffee lands of Angola in the mid-1960s. Now, it's not such a big deal in sort of that part of Western Africa because the primary coffee cultivated there is Robusta, which is largely tolerant. And as I said, I'll get to that in a little bit. What really mattered, perhaps, to a lot of people anyway, about the West African epidemics was then, by this point, the coffee rust was getting very, very close to Latin America's large and susceptible coffee lands. In 1970, almost inevitably, the rust is first detected in Bahia in Brazil. And following on with my discussion about kind of planes, trains, and automobiles, this is the moment where jets become a possible vector for the dispersal of the rust, both across the South Atlantic, and might also help explain how the rust was able to jump from Brazil to Nicaragua in 1976 without really infecting anywhere in between at that moment. Latin Americans made considerable efforts to eradicate and contain the rust, and they couldn't do either. But and so the rust had reached pretty much everywhere in the Americas by 1983. But people figured out ways more or less to adapt to it, and that's something I'm going to talk about in the next shift. But that's a brief overview of kind of the prehistory of the rust and the spread of the rust. I want to turn now and just talk then kind of about the long-term consequences of these global epidemics. And here, I was going to go down a little side rabbit hole, but I'm not going to do that. I'm just going to talk about some of the long-term consequences. One of the things that happens that I'm sure some of you know about is that essentially in places the global coffee frontier shrank. And one of the things that really has become apparent to me as I've written this project, and I'm sure is apparent to a lot of you, is that we think of certain places as being sort of coffee producers since time immemorial. And in fact, in a number of cases, the places of histories, the histories of places that grew coffee are far more recent than you might think. And also, a lot of these places are far more fragile. I mean, the iconic case here is Sri Lanka, Ceylon, where basically the coffee producers en masse abandoned, in part largely driven by the rust, en masse abandoned coffee to cultivate cinchona, which was a plant that was used to make a medicine, a product that controls malaria, and then perhaps more famously, tea. The interesting thing was the adaptation on farmers varied a little bit. European settler plantation owners switched to cinchona or tea, and smallholders, Sinhalese farmers, tended to switch to cultivating coconuts. In much of the Dutch East Indies, people who had abandoned arabica switched to rubber, likewise in Malaya. And so in a lot of the places where there was a large-scale abandonment of coffee, it didn't necessarily mean the collapse of the planter class. It just meant that the planter class shifted to another commodity that could be grown in the same landscape. The other thing, though, and this is part of a larger story, is that this is a moment where farmers really where basically the world of the host starts to change and the world of coffee itself starts to change. Up until the mid-19th century, let's say most of the coffee that was cultivated in the world was probably what we would now call a typica or a Bourbon Arabica. And it's after the rust that there was a real impulse, a global impulse to start looking for new Arabica varieties and perhaps new species of coffee altogether that might work better in certain landscapes and that might be resistant to the rust. And one of the first of these is Liberian coffee, a West African coffee that people initially thought would be resistant to the rust and enjoyed a certain amount of uptake in Ceylon, in Malaya, and also in parts of Java. And you can see this lovely, lovely image on the left-hand side from a book boosting Liberian coffee. And to the left, you can see this sickly old terrible Arabica tree. And in the middle, you have this really kind of awesome looking Liberian coffee tree. And it's like, why would you not cultivate Liberian coffee? And from a market perspective, it was really interesting because at least for a couple of years, if you look at the literature around it, the market was like, wow, this is a super interesting new coffee, but they couldn't decide whether this was a good thing or a bad thing. If you see on the ad to the right, though, you can see in the middle, Liberia coffee possesses all the strength of Rio, all the fine aroma of Java or Mocha coffee. As it is both heavier and richer than either, less is required to produce the usual quantity for drinking. Anyway, as it turned out, to make a long story short, though, the Liberian coffee proved to be, by and large, not resistant to the rust. And after about 1900, it was abandoned. And it was also abandoned in part because farmers found a new coffee that could also work in areas where farmers had to abandon Arabica coffee. And this is a Central African variety. It actually grows across a lot of Central Africa, almost from the Atlantic through to the Indian Ocean side, not quite. In the late 1800s, some of it was collected in the Belgian Congo, taken up to Colonial Botanical Garden, a commercial nursery in Amsterdam, and then taken to Java, where the scientists and growers there had been amassing vast collections of coffees from around the world, from Africa in particular, looking for something that would work as a substitute for Arabica. Scientists at the government coffee experiment station there did work on selection and breeding and developed a variety that was tolerant, resistant to the rust, and well adapted to lowland cultivation. And so it really took off among both estate planters and smallholders. The only problem, as you all know, was cup quality. But to make, again, a much longer story short, the Dutch state intervened and was able to convince, in particular, the United States to accept Robusta coffee as being legally and commercially coffee, because up until that point, the United States had only accepted Arabica and Liberian coffee as to be commercially coffee. And then the American coffee roasting companies in particular found uses for Robusta, particularly in blended coffees, and then later on in instant coffees here. And so essentially it became, in some ways, a way of adulterating coffee with coffee. And as you know, this has really transformed the global coffee commodity chain at almost every step of the way. So here's a graph. If you look at the left of the graph, in 1900, Robusta was 0% of the world's coffee economy. By 1950, it was about 10%, largely most of that growth in Southeast Asia and the Indian Ocean Basin. From 1950 to 1975, it grew up to 25% of the world's coffee production. And largely due to growth in Central and Western Africa. And then between 1975 and now, it's reached almost 40% of world's coffee production, largely because of growth in Vietnam and Brazil. And it's particularly stunning, this growth, in a century in which the world's arabica markets have been almost oversaturated for much of this period. And it is a sign of just how complicated the world of coffee production and trade is, and how it's not simply a question of demand dictating supply, but also the needs of suppliers to say, we are going to grow this stuff regardless, and we will find a market for it, or perhaps create a market for it. And so this, I would say, even though we don't necessarily read this as being a consequence of the rust epidemic, I want to say this is in fact one of the most significant consequences of the global coffee rust epidemic is the development of Robusta coffee as an alternative commodity. And I would say that particularly after about 1950, it takes on a life of its own independently of being rust resistant. It's just really good in landscapes that are not viable for Arabica because they're too hot or too dry or for other circumstances. So, and so the coffee world looks kind of like this rust map. If you think this is a rust map from 1952, and if you think about it now, most of the countries to the right of the map, not all of them, are primarily Robusta producers. And even today, most of the countries to the left of the line are Arabica producers. It's not a 100% map, but that is really the way the world is divided today. The other thing that the coffee rust epidemic does is, and has done from the very first moment of the outbreak, is develop an incredible amount of innovation, of agricultural innovation. It's a process that continues, that started in 1869 and continues right to the present. And one of the first things I want to flag is just farm level innovation. The British scientist Harry Marshall Ward went to Ceylon in 1880. In 2 years, he did a series of just breathtakingly beautiful scientific experiments in which he just showed the life cycle of the rust. He showed how the ecological conditions of the farm shaped the diseases. And then in 1882, he wrote this beautiful report to the farmers and said, here's exactly how the disease works. Here's why all the methods you're using to control it won't work. Bye. I'm going back to England. And the farmers were understandably upset. And so they just started and continued experimenting furiously on their own with various strategies for controlling the rust. And they even founded a journal, which appears here in the bottom left, of known as a Tropical Agriculturalist, where they could basically trade ideas about the disease. And this, as I said, starts or really amps up a process of farm level innovation that continues to the present. And if you look at some of the things they're trying, I'll just flag the one up here, top left. They're dropping carbolic acid on their farms in trying to control the disease. Over other forms of innovation that come to coffee farms that weren't there before is the development of chemical control. After a lot of kind of crazy experimenting with chemical controls, I mentioned carbolic acid. They also tried mercury. I don't even want to imagine what those farms look like. They settled on something called the Bordeaux mixture, or copper sulfate, and it worked well at controlling the diseases. But one of the things that all forms of chemical control did pretty much was that they increased the cost of coffee production. You have to pay for the technology, you have to pay for the chemicals, you have to pay for the labor. And furthermore, the chemicals didn't always work equally well in all environments. And so the uptake has varied a lot over the 20th century. They became more commonplace after World War II when large chemical companies started manufacturing these on the large scale. And later on in the 20th century, you see the development of new kinds of fungicides, systemic fungicides that you can use in smaller quantities and are taken up into the plant tissue. Another thing, which of course is a huge story all of its own, is the development of breeding. So earlier I talked about Liberian coffee and Robusta coffee, which are kind of whole plants. Increasingly, people, there's this in mid-century, there's first of all a development and emergence of all sorts of new coffee research organizations, which can carry out kind of long-term research programs in ways that individual farmers on their own couldn't. And so there's the Instituto Agronómico de Campinas in Brazil, Cenicafé in Colombia, a dedicated coffee rust research center, the CIFC in Portugal, eCafé Costa Rica, the regional cooperative organization Prome Café, and a whole bunch of others. And so one of the things that the rust helps create then is this kind of, or accelerate, is this institutionalization of innovation in agricultural research. And some of the things that come out that sort of shape the discourse of the rust, first of all, are the dwarf coffees, which are susceptible, but which can be used in conjunction with chemicals and still be productive. Then the Timor hybrids, which are based on a plant discovered in Timor that was a spontaneous plant cross between Robusta and arabica, which after several decades of breeding has resulted in varieties like the Castillo variety produced by Cenicafé in Colombia and others. And then more recently, of course, there's the work, the F1 coffees that are being developed by World Coffee Research, our hosts today, which are a new generation. So the F1 coffees, I think you have to see, is just the latest iteration in a larger process of research and innovation that was developed by the rust. In the 1970s, all of these kinds of things were bundled together into a package called, which was known sort of as technification, which focused on intensive production, use of high chemical inputs and fertilizers, and hybrid varieties. It worked very well for some farmers, but as I say here in the final comment, it wasn't necessarily a panacea. And of course, as you all know, research on this continues in other areas as well. And what I want to point out is a couple of sort of concluding the innovation section is I just wanted to say that this is what you're seeing in operation here is what some American economic historians describe as the Red Queen problem. And they take this from Alice Through the Looking Glass. And the Red Queen at one point tells Alice, we have to run faster and faster just to stay in place. And the economists were talking about this in the context of the American farmers, but it works well in the case of the coffee rust too, which is in many cases, the story of the coffee industry since the coffee rust broke out has been a story of needing more and more and more innovation, in many cases, just to keep the farm going. Now, I don't want to be one of these guys who said it all comes down to only the rust. I mean, you all know there's a lot more going on the farms than this. But the coffee rust has certainly been a major lever in this sort of necessary and accelerating innovation that is required to keep the modern coffee industry going. As I go through this story of long-term changes, though, I want to spend a few minutes talking about one thing that did not change that a lot of people did. One of the stories that you will hear often about the coffee rust is that it explained that the coffee rust epidemic and the collapse of Ceylon's coffee industry explain why the British drink tea. And I've heard any number of versions of this story. And here's one that I found in print, where a couple of plant pathologists in the 60s write, It was natural and loyal then for the English to take to tea drinking when Hemelaevastatrix wiped out the coffee plantations in Ceylon. Had the rust not destroyed the coffee trees in the 1880s, the English would likely still be using coffee by the hundreds of millions of pounds per year. As it is now, tea is the national stimulant. The British now drink 9 cups of tea to 1 drink of coffee, and the art of brewing a fine cup of coffee, it has been said, has been entirely lost by the cooks of Britain. I'm happy to say that from all I hear about coffee in England and from my recent experience, I can say it's much better than that. But the broader point about the collapse of the coffee industry leading to a change in consumption patterns in England it's a great story. I love this story. I told it often when I started this research. There's just one teeny tiny little problem with it, which is it's completely false. Here, I did a little graph just so you can see. The red line shows the decline of Ceylon's coffee production, and these are just percentage graphs. So the absolute numbers here, while they both refer to volumes of coffee, are wildly different. But in any case, you can see the red line shows Ceylon's coffee production imploding, and here you can see that as Ceylon implodes, UK coffee imports remain pretty much unchanged. And the answer and why did they remain unchanged? They remain unchanged basically because Britain, like every other major consuming country, gets its coffee from a bunch of different places. So if you look at this list, which was published in 1884, right kind of as Ceylon was plummeting, you can see that even at that point, Ceylon was not the principal exporter of coffee to Great Britain. And it was, and there were plenty of other places that Great Britain was getting its that was getting its coffee from. So apart from just busting that particular myth, and I hope driving a stake through the heart of that myth, even though I do it with some regret, I think there's also a point about a larger point to be made about the coffee rust and the distribution of risk in the coffee industry. And that is the rust has almost always been either a national or a regional problem. It has rarely been, at least in kind of its catastrophic epidemic form, it has rarely been a disease that affects all producing areas all at once. And so because of that, even as individual regions might collapse, other regions have come in and picked up the slack. And that is why, to a large extent, the rust has been infinitely less visible to the world of consumers than it has been to the world of producers. So I see that I'm about 3 minutes over, and I'm happy to see that this is my last slide. So I hope, at least if nothing else, I've given you a good overview of the rust and given you some sense of how I argue natural and social processes have combined, first of all, to shape the rust, and then also to trigger long-term changes in the global coffee industry of one sort or another. Thank you very much. Is Hannah there? Is anybody there? I'm lost. Hello? Hello? Let's see. I have everybody. I seem to have lost Hannah here, and I can't hear anything. Hannah, if you're out there, could you send me a quick text?
Can you hear me now, Stuart? Can you hear me now, Stuart?
Yeah.
Okay. Hi. I'm so sorry, everyone. I dropped out at exactly the wrong moment, but such is the world we're living in right now, the virtual world. For those of you that are still with us, we are going to have some questions for Stuart. So please feel free to drop your questions into the Q&A panel. I know the chat panel is also open. If you can put them in the Q&A panel, that helps me see them all in one place. So Stuart, thank you so much. This was like incredibly fascinating. And even though I've read your book, I somehow managed to still learn a lot in this talk. So I really appreciate it. So one of the questions that we have goes back to the kind of prehistory of rust, the early history of rust. And it's why was rust never established in Yemen? And is it still likely that rust would not attack coffee there?
That is, there hasn't been enough research on that done. I think it has to do, first of all, my understanding is that Yemen is particularly relatively dry, much dry, and that in many cases it has to be irrigated, and so under those dry conditions are not propitious to the fungus. And then I think there are also, from what I understand, extremes of cold and heat that also make it, again, not hospitable to the rust. There's this really cool guy who I'd like to write a bit more about, a coffee expert called Pierre Sylvain, who wrote in the 1950s. And he's one of the few scientists I know who's really, and this is work from, I think, the 50s or 60s, who's done research on this. And if anybody's interested, I can direct you to the paper, but it's also in the book.
Mm-hmm. We have a number of questions coming in that are a little bit, I'm not sure, they might be outside your wheelhouse, they might not, we'll find out. But about the kind of technical management of rust. You talked about some of the early trials that happened, the early research that happened in Ceylon, and some of the failed management approaches for rust. Can you, specific questions that people are asking are about, is fungicide effective? What is the role of shade? Do you have the ability to talk about any of your insights into this?
Well, I think part of the answer is fungicide effective. I think a lot of my cop-out academic answers would be, well, it depends and it's complicated. Let's see, how can I do this? I don't think I can answer, I can provide general answers. One of the things that's clear from some of the studies I've seen, for example, is if you, for example, rust is less serious on, for example, things like complex agroecosystems. But in many cases, those, again, from what I've seen, a lot of those complex agroecosystems are far less productive than say more intensive agroecosystems. And so again, many of you who are farmers out there will probably know there's so many complex variables to take into place that I don't think there's any sort of single answer to this. Look at this, I'm getting calls too.
Well, it was a perfect intro. You said many of you who are farmers, that we'd be really interested, as you're asking us questions, to hear your answers to this question about kind of where in the industry or where in the world do you sit. I have a really interesting question here related to the kind of how historical trends interact with production trends. You mentioned that early on Arabica began to be transferred to highlands because rust was less prevalent there. Do you have a sense of whether this was kind of the beginning of planting coffee at higher altitudes?
I think it was, and I know I was talking to Jim Waller, who's a British scientist who worked in Kenya for a long time, and he said, well, what happened was they used to initially plant coffee all over the place in Kenya, and then essentially what happens is the rust knocked out knocked out production in the lowlands. And then there's also another, I think it's the coffee berry disease, that is a high altitude coffee disease. And so he said, if you look at this altitude of where coffee is cultivated in Kenya, it's basically cultivated in this band that is high enough that the rust isn't that serious, but low enough that the coffee berry disease is not that serious. I forget whether it was the CBD or perhaps it was the borer, but one of those things.
This is kind of a related question. So that's about this kind of a altitudinal shift in where production might have happened because of rust. Other than the Ceylon outbreak, are there other like locations that you can point to that have shifted out of coffee production altogether because of rust?
Malaysia is a big one, and part of it, the question also depends on what you mean by coffee. Because if you mean Arabica coffee production, then I would say most of Indonesia, not all of it, clearly. But they found Robusta to be a good substitute. But of course, it's kind of a different commodity chain. And Robusta is huge. Philippines is another one. I mean, a lot of the most heavily affected ones were in the Indian Ocean basin, and part of the story there is that I think they pushed the Arabica coffee frontier to much lower altitudes before the rust was present, and so these were warm, wet lowlands that were just again ideal for the rust, and so they got hit really, really hard. Yeah. This is an interesting question. So Kyle writes, it's my understanding that Ethiopia was still fairly closed off to Europeans in the 1860s. Yes.
Has it been confirmed, like through genetic testing, that the rust that hit Ceylon was identical to the types that came from Southwest Ethiopia, or is it possible that it may have come from elsewhere?
I think it's possible it may have come from elsewhere. My sense, more likely, is that it came from somewhere in the Great Lakes area of Eastern Africa, and because there was Robusta growing there in the wild, and that area was certainly connected to the Indian Ocean basin by trade routes, ivory trade routes, slaves, people, other goods. And so there were certainly people moving from areas in which we're pretty sure the rust was present. Because I think what happens with our story of the rust is because we're so focused on Arabica, we assume, and actually I realize I accidentally gave that same impression in my talk, that the Arabica, that the rust we got must have come from where Arabica was grown. But of course, the rust is a parasite of a whole bunch of different species of coffee other than Arabica, which have a much wider range. So the fungus has a wider range than Arabica.
Gotcha.
And so, yes.
Do you have any sense, or in your research, what's the words I'm looking for? Sorry, I haven't had enough coffee this morning. Is there like a kind of composite sense of what the impact of rust is on global coffee production?
I haven't seen one. No.
Okay. Too local.
It's too local. And I think there is the kind of shock period, right? And then there's a point where it's just kind of like an endemic disease. And even there, I mean, we have to move beyond just thinking about losses to thinking about added costs, right? So, when you think about impacts, it's not just how much production do we lose, but how much does it cost us to sustain production?
The treadmill, right?
The treadmill, the Red Queen, yeah.
I want to acknowledge that we are at the hour and that people have busy lives. So I'm going to go ahead and close out here. Before I close everything down, I'm going to share a couple more handouts in the handout pane. We have a technical manual for technicians on rust management in Spanish, and also a kind of more simplified manual for smallholder producers on rust that's available now in the handouts pane. I'm also going to share a couple of additional resources about WCR's work on rust and breeding for rust resistance. I wish we could spend another hour talking to you and asking tons of questions, because this was just absolutely wonderful and amazing. If anybody is interested in contacting Stuart directly with more questions, I'm going to put his information into the chat panel here. I highly encourage you to pick up his book or read some of his articles. They are so readable. And we are just incredibly grateful to all of you for spending an hour with us, and to Stuart for his time this morning. So thank you, everybody. This has been lovely.
Thanks. It's been a real treat.
All right. We will see you all another time.